So today's lecture will be intended for measures of variability, particularly the interquartile range and the quartile deviation. For interquartile range, we have our formula IQR is equal to Q3 minus Q1, while our quartile deviation QD is equal to Q3 minus Q1 all over 2. Okay, both interquartile range and quartile deviation use Q3 and Q1. So we have to compute Q3. But what is Q3? What is the formula for Q3? We have Q3 equals lower boundary plus 3/4 of n minus cumulative frequency before the third quartile class divided by frequency of the third quartile class times I. Okay, we are going to find now the third quartile class, and we have to construct first the cumulative frequency column. So again, when we are constructing the cumulative frequency column, whatever the value is at the bottom, so we just copy, and then we have 3 plus 5, that is 8, plus 10, we have 18, plus 15, this is 33, plus 10, we have 43, and then plus 7, this is 50, plus 5, this is 55. We have already the cumulative frequency column, and the next thing we have to do is to compute the 3/4 of n, 3/4 of n, 3/4 of 55, and 3/4 of 55 is equal to 41.25. Next, we are going to locate 41.25 in our cumulative frequency column. So 41.25 belongs to class interval 80 to 84. So this is the third quartile class. And since we found already the third quartile class, all we have to do next is to identify the other given. So we have the lower boundary, which is equal to 79.5. We have here the frequency of the third quartile class, which is 10, and then 33 as the cumulative frequency before the third quartile class. Now we are ready for substitution. So we have 79.5 for the lower boundary, and then 3/4 of n. This is already computed, and that is 41.25 minus cumulative frequency before the quartile class, that is 33, divided by the frequency of the third quartile class, which is 10 times I, which is equal to 5. Simplifying these values, the result is 83.625. So that is for Q3. Now we are going to compute for Q1. So Q1 is equal to the lower boundary of the first quartile class plus 1/4 of n minus cumulative frequency before the first quartile class divided by frequency of the first quartile class times I. Okay. We are going to look again for the value of 1/4 of 55. So looking for the value of 1/4 of 55, 0.75. So we have 13.75. 13.75. Okay, next, we are going to find the equation of 13.75. So 13.75, we cannot take 65 to 69 because the cumulative frequency of this class interval is just 8. So next step is 18. So the the correct or the location of 13.75 is at 70 to 74. This is also where the um, first quartile class, this is also the position of the first quartile class. Okay, since this is now the first quartile class, so we are going to look again for the lower boundary of the first quartile class. In this case, we have since 70, we have 69.5. This is the frequency of the first quartile class, while 8 is the cumulative frequency before the first quartile class. We are now ready for substitution. So we have 69.5, and then we have 1/4 of n. 1/4 of n is 13.75. So we have 13.75 minus cumulative frequency before, which is 8, divided by frequency 10 times 5. Okay. Simplifying these values again, the result is 72.375. Now, we are ready to compute for the third quartile class or the interquartile range. Interquartile range is equal to Q3 minus Q1. So our Q3 is 83, 83.625, while our Q1 is equal to 72.375. So the interquartile range is equal to 11.25. How about our Q3? Or how about our quartile division? So our quartile division is equal to, all we have to do, since we found already that the interquartile range is equal to 11.25, so 11.25 divided by 2 is equal to 5.625. So this is now the quartile division, and we have the interquartile range.